We saw in the last part of this program how screws and gears are used in a rotary positive displacement pump. The screws and gears provide the rotary motion that forces a liquid from the pump's suction to its discharge. Besides screws and gears, many other devices can be used to provide motion in rotary pumps. We'll look at a few different types of rotary pumps in this part of the program. The first one that we'll look at is a lobe pump. Lobe pumps are a lot like gear pumps in that the process liquid is trapped in spaces and forced out the pump. But the moving parts in a lobe pump are a little different. The lobes are attached to the ends of these rotating parts. The lobes are closely spaced, forming a seal between them to prevent liquid leakage back to the suction. The lobes are also smooth, and that, plus their shape, prevents one lobe from meshing with the other, as was the case with gear pumps. Here's how the pump works. The process liquid flows into the suction of the pump. As the lobes turn, liquid is carried in the spaces between the lobes and the casing and is forced through the pump discharge. Lobe pumps are often larger than screw or gear pumps. Here's an example of a lobe pump that's used in a lube oil system for other pumps. The pump in the last illustration is commonly referred to as a two-lobe pump because each rotor has two lobes on it. Lobe pumps can also have as many as 3 or 4 lobes, depending on the pump. Another common type of rotary pump is known as a rotary vane type pump. Rotary vane pumps use a kind of sweeping action that pushes a liquid through the pump. This particular vane pump is commonly called a sliding vane pump. The pump shaft is attached to a rotor that turns with the shaft. The rotor is offset away from the center of the casing. The pump suction is here. Its discharge is around on the other side, which you can't see here. The rotor contains vanes, which are housed in slots inside the rotor. The vanes can slide into the center of the rotor or toward the outer edge of the rotor. As the rotor rotates past the suction, centrifugal force causes the vanes to slide outward, trapping the liquid. This creates a reduced pressure that forces more liquid into the suction. The vanes then sweep the liquid along this path and carry the liquid to the discharge. We'll use this illustration to describe how the liquid gets to the discharge. The suction is here, and the discharge is here. This is the rotor, which is slightly offset from the center of the casing, and these are the sliding vanes. Remember, the vanes trap the liquid at the suction and carry it toward the discharge. At the discharge, the pumping area narrows. Liquid can't flow back to the suction, so it's forced out the discharge. The vanes then slide outward to pick up the liquid at the suction, and the process repeats. The vanes in a sliding vane pump are often made of a plastic or a carbon material. These materials offer little friction, so they don't wear that fast, even though they're in constant contact with the pump casing. Some vane pumps operate a little differently, like this one, which is often referred to as a flexible vane pump. A flexible piece is connected by a shaft to the pump's driver, which isn't shown here. The flexible piece has a series of vanes attached to it. The vanes are made of a flexible material, such as rubber or plastic. They rotate around the inside of the pump casing and keep a tight seal with it by bending at places around the casing. Liquid flows into the suction of the pump and is trapped between the vanes and the casing, much like the other pumps we've seen so far. The action of the vanes traps the liquid and pushes it out the discharge. The big advantage of using flexible vanes is that they bend to form a tight seal with the casing. This principle is used extensively in pumps that draw a vacuum on a process. The flexible vane pump we just looked at can also be used for caustic and corrosive applications. Since the rotor is often made of rubber, plastic, or some other flexible material, the pump can operate in many caustic or corrosive environments. In some other applications, it's critical to keep the process liquid away from all of the pump's moving parts. This type of pump is one of many that can be used in those cases. It's known as a tubing pump. The pump is small and basically self-contained. The process liquid flows through a tube that runs around the outside of the pump. A series of rollers, here, is mounted on a rotating cam that is attached to the pump's driver. As liquid enters the suction, the rollers compress the tube that contains the liquid, trapping the liquid inside the tubing. The rollers then force the liquid through the tubing and finally through the discharge. Since the liquid flows through a small tube, the tubing pump doesn't have as high a flow rate as some of the others we've seen, but it does have several uses. It's often used as a sampling pump for corrosive or toxic liquids. The advantage of a tubing pump is that the liquid doesn't come in contact with any of the moving parts of the pump. A tubing pump is just one of many types of rotary positive displacement pumps. During the past few minutes, we've looked at a few different kinds of rotary pumps, each of which uses a different rotating device to push or positively displace liquid. Up to this point, we've seen how different types of positive displacement pumps operate. Your job will likely include starting up and shutting down a wide variety of positive displacement pumps. We'll examine a typical startup and shutdown sequence for a reciprocating pump when we come back.